Now let's move on to a more challenging example. It's called the fire snake. Don't try this at home. This is a dish of sand, which I am now treating with a highly flammable liquid. Zoe has 20 grams of sugar, and Izzy has 5 grams of baking soda. Now let's mix them together.
This mixture now weighs 25 grams.
Excellent. Let's pour that mixture onto the sand and light it on fire.
Snake!
Relax, it's not a real snake.
It looks like a snake just grew out of nothing, but all it was doing was foaming. Burning this mixture creates a lot of carbon dioxide gas. All the bubbles make it appear really big.
So where did all this stuff come from?
Remember, the law of conservation of matter tells us that when matter changes form, it's conserved.
So, when you take out all the gas bubbles, it should weigh about the same as the stuff we started with.
Let's try it out.
Be careful, Zoe. Snakes can be very unpredictable.
Again, Bert, it's not actually a snake.
This one weighs a little bit less than 25 grams.
Where'd the rest of the matter go?
Some of the matter became a gas and escaped into the air while it was burning.
So it's the same amount of matter, it just simply changed forms?
Labracazam. We just saw when matter seems to appear. Now let's look at the opposite, when matter seems to disappear. This is a piece of dry ice. It's made of carbon dioxide gas.
Hey, that's the same gas that's in carbonated drinks.
When carbon dioxide gas is squeezed really, really hard, it turns into a solid. My mom had to find out the hard way.
Jeffrey! I ordered this ham from the old country. Look, it's on fire!
That's not smoke, Mom. That's carbon dioxide gas made by dry ice getting warmer.
I know smoke when I see it. Curse your ham on fire!
But dry ice doesn't actually melt, does it? That's why it's called dry ice?
Right. Dry ice changes directly from a solid to a gas without becoming a liquid first. So it's perfect for shipping things like frozen foods. When I put this piece of dry ice on our scale, we can see that it weighs 243 grams.
Actually, now it weighs 242 grams.
Wait, now it's saying 241 grams.
Is it getting lighter?
As you can see, it's turning into a gas. If we waited long enough, the whole chunk of dry ice would turn into a gas. It's almost like it's disappearing.
How can you prove it's turning into a gas?
I can show you. First, let's weigh all of our equipment on the same scale. We're gonna use a flask, a balloon, and a few pieces of dry ice.
Altogether, it weighs 152 grams.
Great, now we just put on the balloon. Now we wait.
The dry ice is getting smaller and smaller, and the gas is inflating the balloon.
That's so cool. But look, the weight isn't changing.
The dry ice is not disappearing, it's turning into a gas. The total weight of the matter is the same, even after it changes form.
Because the matter is conserved.
I get it now. Let's explore some more examples around the house with some real-world science. We can see the law of conservation of matter all around us, even in our own homes. Check this out. I put the candle on the scale to show what happens to its weight when the candle is melting. It looks like it's disappearing, but the fire is turning the wax into water, vapor, and carbon dioxide gas. The candle isn't being destroyed, it's transforming into gas particles you can't see with your naked eye. Yeah, these are raw cinnamon rolls. They're dense, kind of like clay. You wouldn't want to eat these. When we bake them though, it seems that they're getting massive.